Hello guys, my name is Balakrishna Srivastav and welcome to Code with BK. So in this video, we learn about what are linked lists in C programming and we understand the core concepts, the very basic concepts that go behind creating a linked list in C programming. So before we begin, it is a request to please subscribe to my channel. And if any of my previous videos or this video has helped you out, so please do subscribe to my channel. So before we start about linked lists in C programming, it is my strong recommendation that you understand pointers, structs, struct pointers, pointer inside a struct pointer very clearly. I've already added a lot of videos covering all these topics. You can find the link of those videos in the description of this video. So make sure that you understand all these pointers, struct pointers, pointer inside a pointer concepts very clearly before we start this. Okay. So we start with linked list in C programming. So we understand first thing is what is a linked list. Okay. So linked list is basically a data structure. Okay. We have multiple data structures in computer programming, and data structure is nothing, it's just storing data in a structured way, and the structure that this stores is nodes linked together. Okay, so we have node objects, or you can say node objects, since C is not object oriented, right? So you do hesitate using the word objects a little, but when we create structs in C programming, we generally call it a struct object. Okay, all right. So we see what are nodes, and we also see what do we mean by linked together. So visually this looks something like this. For example, if I want to store values 233, 897. Okay, this visually would look like 33, 897, and the next of last node is null, and your head is here. So this is how we typically represent a linked list visually. Head is pointing to the first node, the next of the last node is null, and this arrow represents the link that is from this node. Each circle with a value inside represents a node. A node contains a value which is number written. It could be any value. You can have a linked list of characters and any other primitive type as well. And this arrow is the link to the next node. From one node you can go to the next node. That's what we mean by linking them together, and that is what makes a linked list possible. Okay. All right, so this is just an introduction, not going into too much detail. In very short, I'll try to make you understand why do we need linked list. For example, if you want to store these values in an array, okay, so you do something like int arr equal to 233, 897. Okay, now what if you want to add, say, a value between 33 and 8, say 45? The number of locations that you have in an array are fixed. You cannot add or remove a location. If you want to insert a value 45 in this array, you have to create a new array with the value 45 between 33 and 8. So you do something like you get a new array 33, you insert 45, okay, 897. That is to say that you'll have to create an array with one more the size of this array and insert 45 at the right index. And suppose if you want to remove the value 100 here, again you cannot remove a location from an array. You'll have to create a new array with one less the size and remove the value that you don't want to keep in this array. So we remove 100. Okay, this entire recreating an array is tedious when you continuously want to insert and remove values. So we have linked lists. For example, if you want to insert, say 45 was it between 33 and 8, right? So we create a new node which say is 45. We link the next of 33 to 45, and we link the next of 45 to 8. Okay, so the list now is 233, 45, 897. Okay, so and if you want to suppose remove 100 from this, we can say set the next of 8 to 97 instead of 100. So this link is lost and this new link is created, and we lose this node. And now the linked list looks like 233, 45, 897. Understanding this very visually. Okay, all right. Coming back to these 2 points, that it's a data structure made up of nodes and linked together. So node is something that has data and link to next node. Okay, so this circle thing with the value inside is the value, the data, integer in this case, and link to the next node, that is the next node that you can go to from this node. Okay, we can have, say, a linked list of, say, characters. Okay, and null, okay, and head is here. Okay, all right. So to represent something that has data and has a link to the next node, we have a struct in C programming, okay, that has, say, int data. I can say int x is the data, And how do we reach the next node? It has a pointer to the next node. Okay, very standard node structure. And the idea of having a node that has a value and the link to the next remains the same across other programming languages as well. For example, in Java, you have a node class that has data and reference to the next node object. Okay, same with C++ and all. Okay, so in order to create something that looks like this, we have a node represented by a struct that has a data and the link to the next, and this is allowed. Struct node pointer inside a struct node is allowed. For example, if I go back to my code and I say struct node, it has the data int x, and I say it has also a pointer to the next node. Okay, so usually the name of the variable that takes you to the next node from this node is named next, and again this is the same across other programming languages as well. Okay, so we have a node struct that has the data and it can take us to the next node as well. Okay, so explaining this part, that what are nodes, visually we represent it like this. It is actually a struct in C programming that has data and a way to move to the next node, a link to the next node, and this data and link to the next node is same across other programming languages. In C we do it as struct node. Okay, and the second thing is linked together, means we have this pointer within this struct that takes us to the next node, which I'll explain when I create struct node objects and I show you how we link them together. Okay, so this is the struct node for something like this, for a linked list that can store integer values. For something like this, a linked list that is storing char values, the structure remains very similar. You can name the struct node. The data is now char c, takes you to another node of type, takes you to another node as well. Okay, all right. For most of our examples, we are going to use integers as the data inside the linked list node. So when we cover all the parts of our linked list in C programming, we see how we can change the data here and make it to something else. Okay, all right. So explaining you people what are nodes, hoping this is all clear so far. What do I mean by linking them together? I'll just explain it in a moment. And node has data and link to the next node. Okay, this is what we usually represent it as. Okay, now suppose if I have in my code, in my C code, I have struct node n1. Okay, creating one node, struct node n2. I'll say the data inside the struct node n1 is say 2 and n2.x is say 33. Okay, so in this part of the code, what happens in my memory is, I have told this in the previous videos, I explained how structs and struct pointers work, is that you get memory enough for one single struct. Okay, now the struct node has x part and we go with this one. This is an alternate if you want characters, right? It has an integer part and it has a pointer to the next node. Okay, that it has a variable next that can store the address where another node can be stored. Okay, so it has x and it has next. Okay, when you do something like this, there are just garbage values inside. Okay, so this is your n1 of type struct node. Okay, similarly you get n2. Okay, garbage values, n2 of type struct node. Okay, so this line, okay, will give you this line will give you this. Okay, then you say n1.x is 2, that is the x component of this n1 gets 2, so this value is now 2. Okay, next is still a garbage value, it is some address and we are not sure if that address is pointing to another struct. Okay, this is the while pointer, right? Okay, then we have n2.x is 33, so the x component in n2 goes to 33. Okay, now if I do that, n1.next is the address of n2, because n2 is also a struct node. So address of n2 can be stored into a struct pointer, which is n1.next. Okay, so n1.next is a variable that can store an address where a struct is stored. So it is storing the address where n2 is stored. So you can say this next is a pointer to n2. All right, this is how we are connecting two nodes. So let me just write code and just test this out. So I say I have struct node n1, I have struct node n2. Okay, I say n1.x is 2, n2.x is say 33. Okay, all right, and I say n1.next is address of n2. Okay, compiling all this and running, everything is fine. Okay, no output because you have not printed anything. So when I print n1.x, Okay, this is obviously going to be 2. Okay, n1 dot x is going to be 2. Okay, because which is this thing. When I say n1 dot next, I can assess n2. Okay, I can assess n2 using this variable. I can also assess the values of n2 using n1 dot next. So if I say print x of n1 dot next, that is basically the printing the value of x in n2. Printing x in next of n1 is basically printing the x of n2. So if I print n1 dot next dot x, okay, since this is a pointer, I have to use pointer notation arrow operator. Okay, right? So this is going to give me 2 and 33. If I change this to say maybe 100, I get 100 as my n1 dot next dot x. Right? So you see we have 2 nodes. Okay, I can say them they are node objects. They are 2 structs, node objects, and you're linking one node from the another node. Okay, so if we have multiple nodes linked together and we have the reference to the starting node which we are calling the head, we have our linked list. Okay, so if I create say 5 more nodes, I'll say n2, n3, n4, n5. Okay, I have n1 dot next, I'll say n3, n4 and n5. Okay, and I take values 897. So 8, this is keeping this 33 and 97. All right, so when you create 3 more nodes, okay, I have 3 more nodes. Okay, so I'll say this is n3 of type struct node. Okay, n4 of type struct node. Okay, n5 of type struct node, and they all get x and next, which are all garbage values. X and next, all garbage values. X and next, all garbage values. Okay, n3 dot x is 8, n3 dot x is now 8, n4 dot x is 100, n4 dot x is now 100, n5 dot x is 97, n5 dot x is 97. Okay, creating 3 now modes, setting the x values inside them. Then I say n2 dot next is address of n3. Okay, now the next pointer inside n2 will be pointing to n3. Okay, because it is storing the address where n3 is stored. So this is not garbage, this is now pointer to this. Okay, then I say n3 dot next is storing the address of n4. Okay, so next of n3 is now a pointer to n4. Okay, and I say n4 dot next is storing the address of n5. So the next in n4 stores the address for n5, and the next of n5 is null. Okay, the next of this is null. Okay, so let me just redraw this list, which is basically, okay, now compare this diagram with something like this. Okay, we are able to create visually what we saw as a linked list use into our C programming using struct objects. Okay, so if you go back to my programming part, it is all gonna compile and work. Okay, we are just printing 2 values right now, so it's all okay. Okay, so if I keep my head here, okay, which is the address of n1. Okay, so this round thing with a value inside is actually represented by this struct that has a value 2 and a pointer to the next node, which is containing 33. This has 33, pointer to the next node that contains 8, pointer to the next node that contains 100, pointer to the next node that contains 97, and the next pointer for the last node is null. Okay, so visually what we saw as a linked list, we are able to implement it something like this. Okay, so our head is going to be a pointer to the first node. Okay, compile and run. Okay, so if I print now n1 dot next x, okay, so it is gonna print the value in n3. Okay, n1 dot next x, n1 dot next the x component of this is gonna give you 8. Okay, then we can have next and next again, next again. Okay, so this is gonna give you 100, and then finally once more we are gonna get 97. Okay, so printing the values. Okay, 233, 897 within the order that we have explained. Okay, if you are getting confused by the fact that why do I have next n1 dot next and then or arrow operators, because n1 is a struct, it is not a struct pointer, so I use dot. Okay, I do n1 dot next and I do n1 dot next. Okay, but the pointer inside n1, which is of type struct pointer, okay, in order to assess the values within this next, I have to use arrow operator because this is a pointer. Okay, so the values inside next I have to assess using a pointer. Then when I do next inside next, which is also a pointer, I have to use arrow operator, and so on. Okay, I could also do the same thing as using the head pointer. I can say head dot x and I replace n1 dot with head dot. Okay, now head is a pointer to n1, so I use the arrow operator to assess the members inside the head, which are the members inside n1. Okay, all right, so you see the same set of output. Okay, so this is how we create node objects, link them, and this is what is called a linked list. Okay, this idea of linking the nodes remains again the same across different programming languages. In C, we achieve it by using pointers. Okay, now this is a very primitive way to create struct objects, okay, and add and connect them together. Okay, because we have 5 values, so we are creating 5 nodes. Okay, when we need 100 values, we will need 100 nodes for each of those 100 values. Okay, but we don't do it like this, that we have n1 till n100 and then we keep connecting. No. Okay, we use a smarter way. We use dot next, okay, to move to the next node and then keep creating. We'll show that when we insert nodes. Okay, all right. So just to demonstrate the fact that in order to assess any of these nodes, I just need my head pointer, because if I have my head, I can be at my first node. I can go to the next node by doing head dot next. I can go to the third node by doing head dot next dot next. I can go to the fourth node by doing head dot next dot next dot next. I can go to the fifth node by doing head dot next dot next dot next dot next. So head dot next dot next dot next dot next. Okay, and the last of the next node should be null. You got to be careful with this, because by default when we create a pointer in C program, it is not set to null. It is containing some garbage value, some memory location we don't know. Okay, it's a wild pointer, so you have to set it to null. All right, that's why I'm doing this here. Okay, I cannot leave the next of the last node unassigned. I have to set it to null. Okay, that marks the end of the linked list. Okay, so we can write a function void print linked list. Okay, that just needs the head pointer. Okay, to print the entire list. Okay, I'll show you how. I'll just print. Okay, all right, and let me just call this function by passing the head pointer, print list, and head. Okay, head is basically the address of the first node. All right, when I print this, I get my linked list 233, 897, 197 null, just as I represented it here. Okay, obviously I cannot draw circles around the digit numbers. I mean, there may be a way. Okay, that's just extra work. Okay, just saying the nodes which are represented by these numbers, these arrows that represent the link, okay, get us the linked list that we want. Okay, so this is your covering the basic about what is a linked list and how a linked list is formed. Okay, all the functions, printing the linked list, finding the length, inserting nodes, removing nodes, we cover each of these functions in detail in the upcoming videos. Okay, so things you need to remember is you will find something visually looking like this when you are understanding linked list, where you have a circle or a square that represents, and the value inside that represents a node, and this arrow represents the link to the next node. The next of the last node should be null always, and head is always pointing to the first node. If somehow your head moves to the second node, your first node, you cannot go back to the first node because there is no previous link. That is in doubly linked list. Okay, so head always points to the first node. Next of the last node is null. Linked list is made up of nodes. It has data, and linked to the next node we can have data of any kind. Right now this is integer, it can be car, it can be car, it can be other primitive type, it can be a struct as well. Okay, all right, And then we saw how actually a node objects created, okay, and are linked behind the scenes. Okay, this is important that you understand. Okay, and this linking is possible because we can have a pointer to the next node within the struct node. Okay, so we also have something called type def, that is basically used to give an alias, a nickname to an already defined type. It's just renaming so that you don't have to type the long names again. So you can do type def struct node and you can replace it as node. So wherever you type struct node, you can replace it by node. Okay, so let me just compile and run. Okay, so if I replace this lowercase node with every struct node, this is going to be okay. Okay, all right, replacing all struct node by this. So this basically means that wherever compiler will find this node, it will replace it by this. Okay, so you're saying type def this into this. Okay, so you don't have to write this entire thing again and again. Writing one word is much less than writing two words. Okay, all right, so if I compile and run this, I get the exact same output, nothing changes. It's just an alias. Okay, it's just replacing this by this. Okay, we can do type def in the same line as well. You can say type def struct node as node. Okay, so now this means you are renaming this entire struct node as this, so you don't have to do this separately on a different line. It's just the same thing. In this case you are doing type def in a separate line. In this case you are defining the struct and doing the type def in the same line. So again this is gonna be fine, everything is gonna run the same way. Okay, sometimes you will find things like this. Okay, that you have struct node and then this node as well. This works too. Okay, okay, this is fine as well. This will not give you any errors. If I compile, this is fine. I run, that is fine. Okay, no issues at all. But you should not be doing this because your struct node, because you're type defing a struct node into a node. You should do something like this rather. This is better. So you are creating a struct node, okay, and the name of this node starts with an underscore. You are creating an alias for this name, struct underscore node as node. Okay, so rather than using struct underscore node everywhere, you use simply node. Okay, so let me just compile and run. Okay, so what this type def essentially means is that you're replacing every node by this. Again, it is going to be the same output. Okay, so don't get confused with this type def thing. It's just giving an alias. Okay, so I will go by something like this. Okay, all right, so that I can just use node directly. I just have to type one word instead of struct node. Okay, so this was your basics about what a linked list is, how node objects are created and linked together to create a linked list. In the next video we start with something very simple, that how this print list code is working. Okay, we go through the dry run of this, understand how this is working, and then we move on to the parts where we insert nodes in a linked list. Insert at the front, we insert at the end, we insert at middle, then remove operations, then we solve some problems, and that is how we go further. Okay, so I hope you like this video and this was helpful. If there is any doubt, there's a part you don't understand, please let me know in the comments. I always try to answer all your comments, and you can also let me know in the comments if there's a question you want to solve or if there's concept you want to discuss. So please like this video, subscribe to my channel, and thank you for watching.